Similar triangles, a ninth grade conceptual physics video. Two triangles are similar when the angles of the first triangle perfectly match the angles of the second triangle. We say the angles are congruent when they are exactly the same. These two triangles are congruent and not just similar. The angles of the red triangle are the same as the angles of the blue triangle. The sides of the red triangle are also the same as the sides of the blue triangle. If we shrink the blue triangle, keeping the aspect ratio the same, then the angles remain the same while the side lengths change. You can tell that the angles are the same because the blue triangle will still fit into the red triangle in each corner. These two triangles are said to be similar. They have the same three angles, but the red triangle has longer sides than the blue triangle. These angles are congruent, but the sides are proportional to each other. This means that if the hypotenuse of the blue triangle is half as long as the hypotenuse of the red triangle, then the height of the blue triangle will be exactly half the height of the red triangle. When the numbers are simple, it's easy to figure out the missing side. Given the labeled sides, how tall is the blue triangle? It's 7 centimeters because 10 centimeters is half of 20 centimeters, so we wanted the number that was half of 14. With more challenging numbers, we will use ratios to determine the height of the missing side. But first, let's demonstrate how the ratios work with easy numbers. We know the ratio 2 to 1 between the longest sides is equal to the same ratio 2 to 1 between the heights. A ratio is expressed as division, so we can set up the following equation. 20 is to 10 as 14 is to x. This is known as a ratio equation. To solve the equation, we will need to cross multiply. Cross multiplication is a shortcut for multiplying both sides by one denominator, x, and then multiplying both sides by the other denominator, 10, and then reducing. When I cross multiply, I just simply multiply whatever is on the bottom of the right to the top of the left, and whatever is on the bottom of the left to the top of the right. So I end up with 20 times x equals 14 times 10. I've sort of crossed them over. To solve that, we get 20x equals 140, and then I solve for x by dividing both sides by 20. So x is 140 over 20, or 7 centimeters. Try to set up a ratio equation for the following set of similar triangles. Pause the video so that you can try it out on your own. 80 over 60 equals 40 over x is one version of the equation. You could also have written 80 is to 40 as 60 is to x, or x is to 60 equals 40 is to 80. Or possibly even more than that. Anytime two triangles are similar, ratios will help you find the missing side. Try these two isosceles triangles. Find x. 45 is to 20 as x is to 5. X is 11.25 centimeters. To generalize, we can use letters to describe the sides of the triangles. Here we have two similar scalene triangles. We'll label the smaller one with sides A, B, and C. Use capital letters, capital A, capital B, and capital C for the larger triangle. We can actually write one equation for each set of 4 letters. Little a is to little b as big A is to big B. Little a is to little c as big A is to big C. Little b is to little c as big B is to big C. Now determine the missing sides of the two triangles. We're determining little a and little c. Pause the video to give yourself a chance to do this. Little a is 37 centimeters and little c is 31 centimeters. Any part of a triangle is proportional to that same part on a similar triangle. So we can set the same ratios up for the left sides of these two isosceles triangles and their related altitudes. Even though they are on their sides, it's still called an altitude. Ratio math can also help us determine other things that are proportional. The ratio between your arm length and your height is roughly the same as everyone else's. Here we have Molly and Sarah when they were a bit younger. If I make a triangle between Molly's arm and her legs, I can make a similar triangle that should fit Sarah. The ratio of Molly's arm length to her armpit height is the same as the ratio of Sarah's arm length to her armpit height. They fit pretty well.